So apt update, it's generally updating your system um, about the packages and everything. And the main thing you want to do first is there's this huge chunk of so if you can in chapter 5 it's about Ubuntu. Don't worry, these are like properly presented in the PDF which I'm going to share. So this part you have to copy and paste it here. So when you paste, you have to use super paste, that is Control Shift V, not just Control V. I have already installed the required prerequisites and packages, so there's nothing for me to install here. So you just do that and then move on to this line over here. Then you do the again copy pasting, and I won't go through it because I've showed you an example. So this one as well. Don't worry, these are in the document. So these are the prerequisites you have to do, like the supporting packages you have to install before installing OMNet++. And after that, after doing this, so we are still in the directory of the OMNet++ extracted folder. So then what you can do is you have to set the environment variables. Just put this command. It's also in the, everything here is in the document, so don't worry. So it just adds this path to your path folder, so it's fine. And so next we have to run this configuration script for OMNet++. It's this file. So nothing, there's nothing you have to do. Just put // it means you are doing something in the current directory, and you can write configure and just put enter, and now it will start configuring all the stuff. And don't worry, so at the end of this whole thing you have to have this like good. So if there's something bad, it will say bad, or it will give some description of what you have to do. So if it's good, then it's all good. So now, if you're familiar with C, it's based on C. So you just have to make the configured stuff. So this will take a considerably long time. So I'll just stop it. So you just run it, and don't worry if it takes 15 minutes or so. So it compiles every C file step by step, and hopefully it will end up making the OMNet++ software. Then it's very important to run these other two commands. I'll show you here. So make install menu item. So if you don't install this, you have to always go to the terminal to run it. So make sure you do this, make install menu item. It's in the PDF. And also this, so it will have an icon, just the appearance of it. So don't worry about this, just follow the instructions here. And hopefully you will be able to install it. Don't worry if it takes a lot of time. As long as it's running, it's okay. So let's close this and open it again maybe. So you go OMNet++. So you can see it now in the menu. So this is just setting your working directory. You can use the default one. It's okay. And also, if you have any questions, please do ask. So we can discuss, and probably I'll get to you with the answer. So the first thing you have to do, you have to create a project. So OMNet++. You can give a name, class. No. OMNet class. You do next, and you can start with an empty project. It doesn't matter. So don't try to mess with all the settings. Just do next, 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 and finally finish. So you'll end up having this OMNet class folder. So this is your project, and you can do everything here. And one of the most important and resourceful resources is the simulation document which I shared with you earlier, and also these example files. So, for example, TikTok is one of the simple and best examples. You can run this, and along the lines, if you are considering Omnet for your project or whatever, you can also refer back to these projects. That's personally how I learned, and see how they have used these stuff, all these things which you need to do. Probably they'll have been already implemented in one of these projects, so you can go open them and run them, and probably you'll find a solution there. So let's go to the structure. I'll close all this stuff. So the first thing you need to do is to have an initiation file. You can start with an empty file, it's fine. Just skip this for now. So this is your initiation file. So when you run a project in OMNet++, OMNet++ would go to this file, and it will run according to the settings in this file. So you don't have to code everything. There's a form version of this, or like you can go to the source version, depending on what you want. So this is the initiation file. So that's out of the way. And next, oops, the next thing you want is the network file. So let's name it as network. Empty net file is good for us. Just finish. So NED, the name itself is the network descriptor, NED. So it's another language which is developed to describe these networks, and it's very similar to C or like other languages we have seen. So there's not a lot of details about it, about this language outside of this OMNet++ scope. So the best resource for this is again the simulation file. So let's start building a small network, I suppose. Network is the keyword. So you build the network. So make sure the network name you have, the file name you have given is similar to the network you are building. If these names does not match, it won't run. So this is basically the network. You can see now we can see a playground like an area. So whatever we do, we will do this thing. Whatever things happen, it will happen in that playground. So now let's consider an example. Imagine you have two uh, routers or like phones or like devices, nodes, and you want to send a message from one node to another node. Let's for example say that one node measures the temperature, and it wants to send a temperature update every 5 seconds or 10 seconds. So periodically it has to update its neighbor with its temperature. So let's continue in that example. So we have two classes, two node types. or two module types, I would say. So those are simple modules or like compound modules. So you can make simple modules, and each simple module is backed up with a C++ class, and there's a accompanying class for the simple module. So you can write code in that and manage accordingly. And the compound module is sort of a aggregation platform where you can have multiple simple modules, and it's like a group of simple modules. So, for example, you can easily think this as so you can define a compound module as, for example, your computer, and for each OSI layer, I I think you're familiar with like application layer, network layer, Mac layer, and all this stuff. So for each layer, you can define another simple module to carry out the function of each of these modules. And you can so that kind of an architecture can be done. Not only just one layer, you can have for example, you can have a compound module for the Mac layer, and inside that you can have other simple modules carrying out individual functions. So you can arrange the hierarchy as you want. So let's, for example, as for the first example, let's do a simple thing. So we have two nodes and we have to communicate, and let's see how we can do this. So we have two nodes, so I'll name them node 1, and I need to create a simple module for this. So I'll just put it as node. So node is my simple module name, and node 2. So I have to make this node module. We'll do it next. Node. So yeah, so these are my modules. So I need to create simple modules. The easiest way to do this is right click here, new, and there should be yeah, simple module. So I have already given a name for it, node simple module. Finish. So as I said, as I spoken to you earlier, so we have node.cc, node.h. So C++ files have been automatically created for this node simple module. Yeah. Yeah. So the network, you have to have other keywords. I forgot it. Sorry. Submodules. Sub. No, not capital. Yep. So now if you go to the design, you can see two nodes created. You can drag the stuff here and there and create whatever you want. So, and this, and when you do that, there will be additional parameters added. So where's the position of this XY coordinates, XY coordinates, these things you can do it by yourself, or like code it, or like use the graphical interface, whatever suits you. So I'll delete this stuff because it seems a little ugly and complicated, and we don't need that right now. Okay. Now, let's go to the simple module. So hello. Uh,
Yeah, we can hear you.
okay, yeah. If you have any questions, please do ask. I would really appreciate them. So each module, so how it interacts with the outside environment is through gates. So there are a few ways you can implement gates in the nodes. So what you can do is we have this gates keyword inside the module, and you can define input gates in, and in, also output gates, output out. So if you're not really sure whether it's a in or out gate, so you can define in out gates as well. Oh no, sorry, in out, like this. But when you make a gate, you have to connect it to somewhere. You just can't leave it there. So make sure if you create a gate, you actually use it, or else just comment it out or like remove it entirely. So we have done this, and you can, for example, yeah. So that's it. So we have created this simple node, and you have imported that node into the network, and you can see there are two nodes. Uh, that's it for the NED part of things. And next is the C++ stuff. So the luckily because it's in C++, you can bring any domain knowledge in C++ towards this OMNet++ platform. Uh, so if you have any programming knowledge, it's very easy to catch these things up. Are you guys familiar with Arduino environment? Have you used Arduino environments before? Can I have like yes or no quickly? Can people say, okay, typical shyness, I suppose. So let's move on then. So when you open up this node.cc file, there are two methods already there. So when you run this simulation or run this project, the first thing the C++, the OMNet++ would do is run this after running all this like necessary stuff. It would run this initiation file, initializing method. So any initialization stuff you can put it there. And also next, the most important or like the most relevant thing for us is this handle message function. So any message coming into this node file, any message transmitted, for example, from node 1 to node 2, it will end up in this handle message part. So I'm sorry. So whatever the case, any message, it will end up in this handle message. So if you want to write something to amend or like process the data or like whatever, it has to come here. So that's the thing. And moving on to our example, so what we want to do is every 5 seconds, we need to send an update, right? So how we achieve that is, so this is an event-based simulator, as I told you earlier. That is, uh, it run on event to event. So we can create an event, and this simulation would run from that event to the next event, to the next event, and the next event. So the requirement here is every 5 seconds you have to send a message. So there should be a repeated loop saying that, okay, send a message, send a message, send a message. So how we achieve this kind of thing is by using a concept called self message. Self message is just like any other messages. So there are two types of messages in OMNet++, two classes of messages. One is C message, and a child of that is C packet class. So C message class and the C packet class. These two you can use it, and C packet is mainly used towards, as the name says, used as a packet from, for example, if you're sending a message from node 1 to node 2, you'll use packet. If you're using something like a reminder, like a self message, you would use C message. So these are basic. So let's make a reminder message or an event message. So that would be C message. So we are just creating the pointer. We'll name it as self message timer, update timer, timer. And we'll create this integer temperature. That's what you want, right? So this is entering the variable names in your header. Then we'll give some random value for temperature here. Oops. Uniform 1. And now let's take this self message timer and give it new message. Yeah, you can always use control space to get suggestions in this environment. And so here within brackets, you can provide a name, timer, update time. So that in the simulator, you can see, so in the simulator, when the messages are going, if you don't put anything within the brackets, you won't be able to distinguish between what's happening. So like better to put some identifier here so you can figure it out what's happening. And now, so you have to send it this, so you have to send this self message to the future, right? So there's a function for that is schedule at, yeah, schedule at sim time, this function. You can use this sim time function. You can replace this with self message timer. So what this do is if you call schedule at function, so it will schedule a self message, a message to itself in the future. So sim time is the current time plus 5. So 5 seconds into the future, you'll get this self message so that you can do whatever you want with that. So this message, when you schedule it in the future and in the 5 seconds to the future, you'll get this message and it will receive in this handle message part. So what you can do is if, so we can, it's received as message. So if message equal this, yeah, you can write whatever you want, what to happen. So if you can have multiple messages, self messages, timing, reminding of reminding the node to do multiple tasks, and every message would come here. For example, if you want to search the available neighbors, or maybe like if you are like just starting, you need to connect to a network, maybe an ad hoc network, and you need to send some messages, or like any periodical task can be scheduled in this manner so that you can do them in periodicity. So now you have to send the temperature. So now let's create a packet. C packet. Packet. Let's name it update new C packet. Actual update, right? So now we have created the packet. Uh, so this packet would have its own parameters or data fields. Mm, as you can see, the bit length, the duration, uh, things like that. But actually, you want to have um, the temperature parameter as well, right? You have to add, you might need to add data for this to this packet. So what you can do is you need to create a new parameter update, if I correct remind if I remember it correctly, add parameter. So we can add a parameter temperature, and you can set, let's do this and you can set a value. Now and we'll run this again here. So every time we'll give a random temperature value, and it will put that, it'll make a new data field for the temperature, and it will include that, and we created the packet. Now we have to send it, right? Now it will go out through the out gate of this. So we can do send, and you can see the first suggestion. You can put the message and the gate which you want the message to go out from. So we'll use this. So we'll use the update packet, and we'll use the out gate. It has to be, oops, in the within, it is passed as string. So if you run like this, so what will happen is you run it, so it will initiate, the nodes will initiate. At 5 seconds in the future, it will just send an update. And after running this send update line, the simulation stops because that's all you have written, right? So if you want to do this periodically, if you want to like continue this periodically, at every self, after every self message, after you process every self message, you have to schedule the message again so that it will do continue the loop. So you have processed the self message, as in like you got the reminder and you did whatever you want to do, and also you have to again schedule it in the future so that you will get to the same place again and continue what you want to do. So this is a trick, or like this is the structure, very useful structure in all this wireless stuff we can do. So for this can be used like for periodical searching, or like very useful. Mm. So let's I think we can move on, or let's, yep. So this node.ned file, net file, and this node.cc file, those two are combined, or like connected. So that's the thing. So you can do whatever you want. And now, so in this case, we have created the nodes, but we have to connect these nodes as well. So we can use the connection tool here, but you can go to the design and connect this node, oops, this node, connector, this node to this node, and it will ask what gates you want to match. If you have multiple gates, it will be like multiple options, but in this case, there's only one output gate of node 2 and only one input gate of node 1. Just do this. And also you have to connect the other way around. So I'll code it so that you know the both ways. Node 1 dot out dash dash arrow, node 2 now, and out. So this is one way of doing it. oops, int. So yes, is it giving an error? No. Yes. So as I told you earlier, make sure that if you have a gate, you have to connect it to somewhere. Make sure you do that. So this, you have made the connections, and if you go back, you can see two-sided arrow. So it means like connected in the both ways. Now, so there's a main network. So in the initiation file, what you have to do is you have to tell the simulation what is your main network is. So you just can do the control space. Sometimes when you do this, if you have multiple folders, it will consider as multiple packages. So you might have to have, so if you have a package called test, and inside that test package, if you have a network, so you might have to write test.network. So it's a little complicated. What I suggest you to do is like control space, and it will give you a possible networks. You can have multiple networks with multiple scenarios. For example, if you have a scenario with a low density case, you can define a network for that instance. And if you have a high density case, you can have another network. So you can have multiple networks. And when you want to simulate one, you just pick the network you want, and that's it. So yeah, either you can write this as well. Now, so let's try to run this, right? So sometimes when you like we have when you build this project multiple times, the previous build and the current build can make issues with each other, and it might not run, might give complicated error messages. One of the easiest things, and most of the time this works, you can press this clean local. So currently it's an error because there's nothing is built. Uh, so you can use clean local or clean project or both. And oh, we are getting error messages. Okay, we don't we have uniform? It's fine. Let's put like 10 again here. 10, more like plus plus. There's an error. Let's see. I'm also a little rusty because the last time I used this was as Tarakas I told this way back. So let's go to message definitions. Yeah. Oh, let's go to TikTok and see how it's done. So this is the structure. That is the easiest way of debugging these things. Okay, okay. multiple languages in the head. So I think this was the error. In C++, if you put just one comma, it will take it as char to as strings. So hopefully it will be built now. Okay, it's building. Nice. So the error was I just used one comma. So like the single quotation. When you do that, it's the C environment takes it as char, a set of char values. When you use two, double quotation, it will take as a string. So that's the issue. So after building, you can run, say okay, and yes, hopefully this will run without an issue. Okay, now we can see this. So you press run here. So you have few options. You can go to the next step as in the next event of the system. Basically, you can use run, or like when you use run, the simulation will be very slow. So that is run is basically used when you want to see what's happening, and when you want to debug or when you want to present or something like that. It will step by step go to the take the messages and see. But when you want to take results or like to do an asymptotic analysis of the system, we can either use fast or express. So it will like quickly run the whole events very fastly, and yeah, so we can say run. So as you can see, so the messages every 5 seconds, uh, it will send messages to each other. So this is a simple network thing you can do. So we can stop here and stop. Sorry. And also you can use this until function. So this is very important if you know that, okay, for example, if you have this ad hoc network and if you want to analyze something after the individual nodes have connected to the network and everybody is in the network. So if there's a phenomena you have to uh, see after some time, you can use this until function. So we can put like 100 seconds or whatever, and it will run in the express mode for the 100 seconds, and after that it will stop, and then you can press run and see exactly what is going on. And when you run this express and fast, I think you will not get the this event log. Uh, so if you so this is one of the main things you can use for debugging. So when you can go and see node 1, which is the node ID of 2, the first node 1 on self message update timer. So the self message update timer has been uh, uh, so earlier the message has been deployed into the future t equal 5, and at that t equal 5 the self message have been uh, received in the handle message method, and after that so you can see again node 1 sending an actual update to the network. So all the message transfers in this case is very simple. We have only two messages. One is a self message, and one is a packet. So in this case, it's very simple. But if you have multiple messages, you can see everything here. And if there's any debugging for you to do, you can do it here. To actually analyze the results, you can do it here. Mm, let's close this. Yep. So there's another function you can use, finish. Obviously, it's void node finish. So this function can be used so to run at the end of the simulation. So if you are measuring something like a packet drop, you can have a variable for that, right? So you can use this function to write that into maybe a text file or an output file, or do something at the end of the simulation to record your data, or like whatever you want to do. You can use this finish function. You want to see it here. So should I delete it? So one of the other interesting things I want to show you is, so imagine if you have multiple layers, OSI layers, and what does, I mean, we all know that, right? So if the application layer puts out a packet or a message or a datagram or whatever, it sends it to the next uh, neighboring bottom layer, and that layer would encapsulate that message into a frame or a message from that layer, right? So here we can do the same thing. Imagine we have another packet, a Mac layer packet. Let's name it as Mac packet. So we'll do Mac packet. So similar to that, what we can do is, there's a function called encapsulate. And you can put either a message or a packet here. And at the other end, one easy thing to notice, and one of the confusing things is, when you write this code, you're writing for one node, right? But the interesting part is, or like the confusing part is, the same code will be deployed in the node 1 and the node 2 as well. So in one node, in this one code, you have to write the sending part, and also if you want something to happen when you receive it, you have to write it in the same code, in the same, maybe like here, for example. So we send the temperature, right? So if you want to update something on the temperature on the local, this part will be, yeah, handled by the sender. But then again, if you want the receiver to do something, because it's the same node, you have to write something again for the receiver. So this is for the sender. Sender sending the message, and again we can have the receiver receiving the message. So if you want to do something here, if you want the receiver to do something here, the roles are interchangeable. That's my point. So it can be confusing for some people and can be like straightforward for some people. Just think about it. If you have any questions, like let's discuss about it. So so this is the basic of this. And when you encapsulate a packet, sorry, uh, then at the end, on the other side, you can have the decapsulation. Decapsulate. So, uh, so in this case, any message coming here would be like message. So you decapsulate this message to get the received message. So encapsulation, decapsulation, that part you can do. And this is very important if you have multiple layers. You can easily encapsulate the message from previous layer, just as you would do in an actual scenario. So when you say like a Mac frame, you have to have different. Uh, so if you take IEEE Mac frame, there are spaces for like the destination IP, the source IP, destination Mac, and all this stuff. And you need to have a method of defining custom packages oh sorry, packets. So let's look at that. So let's do my packet dot msg. So that message. So packet my. So we are writing a custom packet now. Custom packet. Hmm, forgot. Now here you can define uh, the data fields you want. So for example, I need the source ID. Source ID. I would like the destination ID. So if it's a routing case, I would like maximum hops, max hops. Mm, so things like that, or like whatever you do. But let's this name this as a Mac frame, frame, and we'll rename this message as Mac frame. Okay. So after doing this, you have to run build. So it will create these two classes, macframe.cc, macframe.h. So these classes, so it does not matter like you write this source destination. So there should be get and set methods to set values to this value to these parameters and to get the values from this parameter. So those messages like those handling and all this stuff, uh, luckily these people or the OMNet plus plus takes care of it. So for every so we have created a destination ID parameter, so it has automatically generated the get destination ID method and the set method as well. So it's very easy for you to use custom messages. So how we use these custom messages is that in the node file which you want to use, you can have include within this. We are using file name. What is my file name? Mac frame underscore m dot h header file. Okay. So now we can have this Mac packet as the packet we have already decided used. Mac frame copy and use. So and so we do this now, encapsulation. So ideally this would be in two nodes, but with the time restriction and due to simplicity, I would combine the application layer and the Mac layer into one and just show you how we can do this in a very methodical way. So we have the packet, we create it. So for example, this would be a packet from the application layer, and that would have these custom parameters. This is one way of adding parameters, but if you have multiple parameters, adding all these things and doing this pair thing, it won't make sense. So you just do a custom packet by yourself. So that's what we did for the Mac frame because we have multiple parameters. So after that, we have this update packet and we encapsulate that update packet into the Mac packet by the Mac packet, and we can set the parameters of the Mac packet now. Mac packet, I think dot, yeah, it's this, set destination address, let's say 1 because it's int. So set source ID. So we can have a source ID. There are methods to get an ID from the packet from the node. So I think it's my name. You can just go to the simulation examples and see. And we had another parameter, I can't remember, set. Mm, so whatever, I can't remember. So interestingly, we can do many things like this. But yeah, and at the end, on the other side, on the receiver side, you can see which ID it came from. Like whatever you do here, you can get those data and do uh, multiple functions or like whatever. You can do these things. So that is the basic of the node structures and the basic functions, simple modules, compound modules, messages, packets, self messages. Those are the basics of the ABCs of OMNet++ environment. So knowing these things, you can export this knowledge into other domains or your projects. So as I told you earlier, I would reiterate, just go through these examples and run, build them and run. And these examples would give you big let's run this for a sec. So when you run it, make sure you are running the om or whether if you are, for example, if you are in the node file, and if you click run, it would give an error saying that this is not a network file. Either you have to be in the network file, or you just, the easiest or the best thing is to go to the OMNet file and run it. And if you are in this file, it would still work, but it would work for the previous OMNet initiation file you have been on. So to make things safe, you can go to the OMNet file or the network file and run. So make sure you do that. So I have two initiation files now. So I would go to this one and run it. Save. So yeah, so as I told you earlier, in this example, they have put multiple networks with multiple scenarios. So you can choose one of them and OK and run. So it's like a, we call it TikTok example, as in one message is being bounced between two nodes. So you can see it's a very simple and very good example to begin your stuff on. And let's run some other examples, more complicated ones. TikTok 14, I think. Yeah. So one packet has been, it's been passed around. So you can go to the source files of these files. It looks intimidating, but it's very simple if you know the basics. I would urge you to go there. One of the downsides of this OMNet++ environment, of course, is the wireless aspect of it. Uh, of course, there's this library called iNet. It has many, it's a support library written to implement these wireless architectures and wireless sides of things to this OMNet++ environment. All the other examples are mostly for the wired side of things. So for wireless, you can use this thing, but the problem with this inet structure is that it's very complicated and it's very hard for you to edit and do your own stuff, especially if you are interested in something like that. But it's very easy. I mean, there are examples, a lot of examples. Ad hoc, for example, it's a good DHCP, all the protocols, IPv6 architecture, uh, .d, mm, void, VoIP, all this stuff has been like created on top of this omnet architecture. But the thing is, it's, if you want to change something, it's very hard for you to do that. At least it was hard for me. So to avoid this situation, what I did was I didn't use the inet framework. I just coded whatever I want. But doing that, the issue was uh, the physical layer side of things. I had to code myself. That's so. What I did was, for example, if you want to have a bit error rate, or for example, large scale fading, small scale fading, or Gaussian distribution like Gaussian fading or something, uh, that you have to code it yourself. That's very so. My approach for that was I had this another module. In this case, it's just a simple one module, right? But I defined a compound module having multiple layers, and in the last physical layer, I coded the physical layer phenomena. For example, transmit power, uh, uh, the transmit power, the received power, and also other scenarios or packet drops. If I want to have that, and all this stuff, you can code like coding in any other environment, just like C++. So that's my work around on that. I think if you are doing the same thing, you can do it because like the INET framework is very it's very close to the realistic stuff which you would do, and I think that kind of realism might not be the might not be necessary for like some simple projects we do, or like even for research work we do. So building up your own classes, it's a good option. Uh, so, and also there is another. So me, Dr. Tarak, and fellow researchers were able to like publish a work uh, on this. So this is that. Uh, so in this scenario, what we do is we focused on a vehicular scenario where vehicles, where how to actually prioritize an emergency vehicle in a scenario where in a highway kind of a scenario. So if you are interested, you can go through this paper and find out exactly what we did and the protocols. So what I'm trying to say is this kind of thing can be done, and it's I wouldn't say it's easy, but it's very possible for you to do these kind of things. But so uh, you can do things like that. But for this, for vehicular architectures, we have to use another supporting architecture, just like INET, but it's a little different. It's called, I forgot the name. So it's there's a separate architecture for DSRC. It's IEEE 802.11p, the vehicular communication architecture. That is, I forgot the name of the veins. It's called veins. Uh, if you are interested in vehicular architecture and vein simulator, yep. So this you can use this to simulate uh, uh, vehicular architectures and DSRC related stuff. If you want to develop a protocol and algorithm, which we did earlier, you can use this. You can download it. You can download it as a virtual box, or else you can download the project file just as this INET, and you can import it to here and run it. It's a little complicated. Maybe if you're interested, you can take a look. Uh, so possibilities are limitless, but as I told you, it's more suitable for uh, not for the physical layer, but I would say for the Mac, and like to identify and to analyze the effects of all these other layers. But but that does not stop you from analyzing the physical layer related stuff. You just have to uh, find workarounds on that. As I told you earlier, you can define a layer, you can define a frame, packet frame, and you can do the calculations by yourself and implement it. But for a simple applications or a LAN application, you can use as it is. And of course, this is not the so it was I was trying to give you the basic ideas and trying to give you the basic ABCs of OMNet, and I hope you got it. Obviously, you'll need much more knowledge on this too. I would say much more, like some more knowledge of this platform to create or like build up your own projects. But nothing is impossible in this case because we have a lot of examples like TikTok and other stuff, and in the iNet as well. So I hope you got something out of today's session. And if you have any questions, maybe we can discuss them.
Thanks a lot, Insaf. Any questions for Insaf?
Maybe Luis can ask something, or Dylan.
Uh, Insaf, were you able to talk about other available simulators as well?
Yeah. So one of the other simulators, one of the popular simulators which is being used in the research community is the Kuja simulator. So it's a little different from this. It comes so there's this project called just give me a second. It's basically built towards simulating IoT stuff. Mm, so there's this thing called Contiki. Yep. So Kuja simulator is implemented inside this Contiki operating system. So ideally, you can install this Contiki, some version of Contiki into your IoT devices as well. So that's the basic idea. Uh, so you can download the Contiki virtual image, and as I did, you can go to the virtual box, the virtual simulator, and try to you can import that into the virtual simulator and virtual machine simulator, and you can open up this OS, or you can install the OS, and then there's this a simulator called Kuja, and it also has it's basically based on C because you have to have the C background C codes because you are trying to install what you write in Contiki or like the Kuja simulator directly on the IoT devices. Most of them, we know that C language, you can use that language to make what you call the bytecode and like put it into the memory. So for that cases, it's based on C. So from moving on from OMNet to Kuja, the difference is Kuja is C and OMNet is C++. So that you lose this object orientedness of the code. So you have to code. And if you are working on, for example, 6LoWPAN, RPL, or like any other IoT stuff, I think this is a very good starting position rather than this OMNet because they have already, some people have already implemented 6LoWPAN and RPL and all this stuff there. Again, there's a small issue of like there's a slight steep learning curve because there are a lot of files and you have to figure out what files you have to edit if you want to implement something new and if you want to make changes, where to make. And but at the end of the day, I think there's a lot of support for Contiki in the 6LoWPAN community. So depending on your project, I think you can either choose Contiki or 6Low, no, sorry, OMNet++. Yes, sir.
Any questions from Insaf? Can be about what he talked about today. It can be about his graduate studies or anything else.
So
Okay, seems not. Uh, so thanks a lot, Insaf. And,
yeah, my pleasure.
you did a great job. I have much better than what I could have done. So that's great. Um, can you give them your email